Hello, welcome to Researchers Help. So this video mainly used to create signal Nicholas PID tuning for any plant. So first of all, we have create S equal to TF of S. That means like transfer function. So here we are using a higher order transfer functions. So we have taken the transfer function 6 by s plus 1 into s squared 25s plus 156. So first of all, you just display the plant response without the controller. So when you see this, we saw the graph like response or step response. We got like the one instead of one, it's reached partially stable or unstable the systems. So it's stable in the 0.04 system as amplitude with 7 seconds. So if you would like to identify this step response means when you apply this step response, we have get the both value. That means it's a y-axis value and it is a time value. When you run this, we got the value of y, this much of value and t. So why have we have taken the values means already we know the graph. The graph something like this. So in signal Nicholas tuning, before tuning the case, we want to identify the reaction curve. So reaction curve is nothing but the point is starting from the starting point to this ending point. This means this curve point we need to estimate. So in that estimate we have choosing main parameter. One is our starting time is 0 and our setting maximum value is 1. So the gain is easy to calculate, nothing but y and minus y of 1 divided by d. That means it's a deviation, like it's around 0.04. Then we have calculate the difference of y and difference of t. That means you are just applying the differential term to compute the differential value. Differential means y of t plus 1 minus y of t. So after calculating that, we have identified the maximum dy by dt. So identify the maximum slope. From that slope, we have identified that slope value with respect to y amplitude. So that means that slope maximum amplitude, then their index. So then we have defined two things. One is time constant, another one is time delay. So time constant nothing but there's a deviation divided by this change in deviation, that's means m dy. Time delay nothing but the starting time index, that means the maximum value at which time minus that time constant minus the initial time. So after that we have identified this reaction curve. We have identified three parameters importantly like gain, time constant and time delay. So we have assigned gain as gain and time delay is alpha and time constant is tau. So when you see that, next step, we got the value. So this is a reaction output curve. So that only I mentioned. So you try the tangent line and identify the maximum slope. From that we have identified that ultimate time and ultimate period concept. So after identify these three things, we are going for ZNTunedPID tuning. So already we know we have the standard formula for this PID tuning. Nothing but k is equal to 1.2 tau by k into alpha. TA, that means that integral time 2 into alpha, and TD, differential time 0.5 into alpha. So already we know the equation of the PID equal to Kc, that means the common gain, plus 1 plus 1 plus TA into S, integral term and derivative term. So then we have multiplied this G2 in the PID because we need to apply closed loop process. So before the process we need to multiply G2 into PID. We got the value like this transfer function. Now we need to check closed loop response. So instead of negative feedback, we have just assigned feedback g comma 1 with respect to step response. So from that step response, we have identified the response. So just the closed loop PID response. Yeah, now is stable at level 1. Okay, so then from that we have identified this y and t, that means the amplitude and time value. From that we have estimated the step information. What is this step information? The step information having rise time, settling time, overshoot, so many parameters. Then we have assigned settling time threshold. The threshold nothing but 0.05. That means 5% of settling time. If you need 10% of settling time, then just assign 0.1. Okay, so when you run this code, we got the value of rise time. So everything that graph will be overlapped. Steady state error 0.0028. Overshoot percentage 49.79%. Right? So around the value is 1.49 maximum value. So this value is overshoot. And final settling time 1.1457. That means plus or minus 5% error is happened this point. Then this point. The finally the rise time 10% to 90% time it's taken 0.12275. Okay, so this is the procedure. Now it's a simple code and everything it's having. If you want to like this, then run the code. So the code is step by step execute. So after executing like plan response, reaction curve, and finally the tuning output, we got the 3 graphs. Yeah. Now its settling time is around 3.713 and overshoot is 52.56. So when you assume that you have understood how will we are shown is a 52 the value. So that way we are calculate all the values. So it's for the simple synchronous tuning of PID controllers with higher order transfer function. Okay, thank you for watching.